what is the really case. Then okay. Now consider this. What was the explicit description of the column space of A star? Did you remember? The column space of A star, in the beginning I told you that it's the range of the TA star. In other words, it's the collection of the vectors, say W from Fm, such that A star W. So in other words, column space of A star is the collection of the images of the vectors from the Fm. That's what it is. Now as S belongs to this, then this S must be of this form actually. It must be of this form. So you can say, so there exists a W in Fm such that S equal to A star W. A star W. Okay? Now multiply A onto the both sides of this system. Okay, so take this and multiply A onto the both sides of this system. A star W. Now AS is Y. So this means that A star W is equal to Y. So this means that this system, hence A star U equal to Y is consistent actually. It has a solution. It has a solution. And it can have a unique solution and infinity many solutions as well. So it's consistent. So if it is consistent, then there must be some solution of it. Okay? So for example, W is the solution for now, what do you call this system? So now, consider, so if say U naught belongs to Fm, Fn is any solution, if U naught is any solution of what do you call it, A star U naught equal to what do you call Y, okay, what do you call Y, then X equal to A star U naught, okay, then X equal to A star U naught lives in, by the way, this A star U naught is going to be an element where? So it's going to be an element in the column space of A star actually. It's in the column space of A star. Then X, write it here, X equal to A star U naught, okay, belongs to what do you call column space of A star and solves, and AX is equal to Y, because if X is this, then AX equal to Y. So you found one solution that lives in the column space of A star. But think about the part B. Part B tells you something interesting. So part B tells you that F, the minimum norm solution, is the only solution that lives in the column space of A star and solves Ax equal to Y. And solves Ax equal to Y. And now you found another solution, okay? Now you found another solution of system Ax equal to Y that lives in the column space of A star. So from part B, from the uniqueness, this A star U naught and S can't be different actually. So they must be equal to each other. They must be equal to each other actually. And this completes really the proof of the theorem. This completes the proof of the theorem. Okay? Now here is a remark. Here is a remark. How to find, so if I give you a system of equation based on this theorem, what is the algorithm, what is the method to find the minimum norm solution of a given system actually? If I give you 3 equations and I tell you find the minimum norm solution of it, the question is how to find it. So how to find S, so the minimum norm solution of a system, say Ax equal to y. Ax equal to y. So there are basically 2 steps actually. So this part C tells you a recipe of finding it actually. So the step 1, okay, is forget about this system. This should be a consistent system. Forget about this system. Step 1 is a solve A star U equal to y, where U is unknown. And y is the same y from Ax equal to y. Okay? Solve this system. Imagine that you found the solution of it, U0 actually. The U0 is the solution that you found actually. The step 2, simple, calculate A star multiplied by U0, this solution that you found. This solution, since it lives in the column space of what do you call A star, this is the unique minimum solution actually. This is the unique minimum norm solution. So finding the unique minimum norm solution for a system is really easy. So step 1, solve this system. Step 2, say for example you found solution. Step 2, multiply that solution with A star matrix, and that would be the minimum norm solution of this original equation actually. So let's do one example based on it. Let's do one example based on it. Okay, so here's an example. Here's an example. So imagine you want to solve a system, say Ax equal to y, where A is this matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you want to find a minimum norm solution. Find minimum norm solution, okay, of this system. So where A is this matrix, 1, 2, 3, 4, 5, 6, 7, 8, and X is the set of unknown vectors, X2, X3, and Y is say vector 3, 3, 3. Okay, this is the vector actually. This is the vector. Okay. Now what you need to do? Forget about this system, solve this system. A multiplied by A star with some unknown U equal to Y. So let's first calculate A multiplied by A star. So what would be A? A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiplied by A star is the conjugate transpose, but these all are real numbers, so their conjugate would be the same, so just simply transpose them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And if you're going to multiply them, you're going to get this matrix 14, 32, 50, 32, 77, 122, 50, 122, 194. So this is A star. So hence we need to solve a star u equal to y. So in other words, we need to solve this 14 u1 plus 32 u2 plus 50 u3 equal to 3. Okay, 32 u1 plus 77 u2 plus 122 u3 equal to 3, and 50 u1 plus 122 u2 plus 194 u3 equal to 3. So these are the three equations that you have to, what do you call, solve. So imagine using your any favorite method, you solved it. In other words, you can make an augmented matrix and just reduce it to reduce equal form, or any method that you like actually for solving this. So this system, you're going to see that is consistent and has infinity many solutions. So there are infinity many solutions of this system. Okay. So which is evident from 333. Okay. So you want such three numbers, okay, which satisfy all three equations simultaneously. So there is infinity many solutions actually of this problem. So imagine you found one solution. So let's, out of infinity many solution, one concrete solution is u0. Okay, and say u0 is any solution, 0, 4, negative 5 by 2. I suppose actually. So for example, you found one solution. Okay, this is what it is. Now do what? Your minimum norm solution is the take any solution of this system and multiply it with the A star actually. A star u0. Okay, A star u0. So A star u0 would be equal to what? So if you take, what do you call, 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplied by u0 is really 0, 4 minus 5 by 2. Okay. So S is equal to, S is going to be vector minus 3/2, 0, 3/2 transpose. So this is really the minimum norm solution of the given system. So you can actually check it. So if you compute the norm of this, okay, so in other words, square root of 9 by 4 plus 0 plus 9 by 4, okay, which is going to be a number approximately 2.1213, okay, and solve this original system actually. Find any solution of this original system. Say for example, in this example, one example is given as what do you call, negative 330. Okay, take this factor, negative 330. This is one solution of what do you call this Ax equal to y, and calculate its minimum norm actually. So it's going to be scale 9 plus 9 and under root. So its square root of 18 is the magnitude of it actually. Okay. By the way, this S is the solution of this system Ax equal to y and has minimum norm. Because for example, if you take any other solution like minus 330, its norm is going to be bigger than or equal to this norm actually. So finding the minimum norm solution is not really difficult. So the first step is solve this, find a solution and multiply with A star. So that would be an element that lives in the column space of u0, and you're going to get what you call a unique S. So I hope this makes a little bit of sense to you. So see you next.